Okay, here we are going to look specifically at exponential and logarithmic equations. We are going to look at the properties along with them, and we are going to do examples where we are solving the different exponential and logarithmic equations. So essentially, we are putting all the properties and all of the rules together into one package. So when we're talking about your exponentials, specifically the exponentials, we have to remember that we have that special property, and that property that says if your bases are the same, then your exponents are the same. Okay? And that property is used most often in order to solve your exponentials, that you want to make your bases the same so that you can claim that your exponents are the same. To solve the exponential equations, the first thing you want to do is you want to rewrite them so that you can apply your property. If that is not something you're capable of doing, then you must take the log or natural log of both sides and use your log properties in order to solve your equation. So it basically comes down to what you're actually able to do. Now, some of the properties that you would need to refresh yourself on are the fact that we have the property for equivalence. Equivalence says if you have an exponential equation, you can rewrite it into the form of a log equation. Okay, so we can translate from one into the other. Second, a cool fact to remember is that your exponentials and your logs are actually complete inverses of each other. It's why you can use one to undo the other, which is where our log rule comes into play, which says if I take the log where my log base and my exponent base are the same, then whatever was in the power becomes the answer, and vice versa. If I'm taking the exponential evaluation of a log and my bases are the same, I still have whatever I was evaluating by to be the answer. Now, the other few things that we have is that when we're dealing with the product, we can expand it into the sum. When we're dealing with the quotient of a log, we can expand that into subtraction. And when we are raising to a power, then we rewrite it where it becomes the power times your logarithmic function. So we have to take all of these ideas into account when solving the problems. So let's look at a couple examples here. So first and foremost, I have 4 to the 3x minus 5 is equal to 16. So the first thing I want to do is I want to try and see, can I rewrite 16 into 4 to the something? Okay, this is what I want to try and do. Well, we know 4 squared is 16. So this becomes 4 to the 3x minus 5 equals 4 squared. Therefore, I can apply the rule. So we're going to apply that if a to the x equals a to the y, then x equals y. So this is the rule we're going to apply, which says we can solve the 3x minus 5 equals 2 and find x. So here we need to add 5 to both sides, so 3x equals 7. Divide everything by 3, x equals 7/3. Okay. So now we have 15 to the x is equal to 30. So again, you want to ask yourself, is it possible to rewrite 30 into 15 to something. Well, in this case, it's not. So here, we have to take the log of both sides. So in doing so, right here, we have a power, which says I need to move it down in front. So here, this becomes x log of 15 equals the log of 30. I need to solve for x, so I got to divide both sides by that log of 15. So this becomes the log of 30 over the log of 15. And so here we would use our calculator. So in our calculator, we would do the log of 30 divided by the log of 15. Hit enter. And we have 1.256. So x is equal to 1.256. So here we have the exact. So this right here would be your exact solution. And here you have your approximate solution. Okay, so in this instance, we gave both. Alright, let's look at a couple more. So let's start with number 3. Okay, so here we have e to the x minus 4 equals 4 to the 2x over 3. So the first thing I would do is I would say I want to remove my e because there's no way I can make e and 4 the same base. So in order to do that, it says I have to take the natural log of both sides equals the natural log of 4 to the 2x over 3. And then this part right here is a power. So powers come straight down here. And then the other thing we know is that the natural log of e, these are going to undo each other, thus removing e from my problem, and on this side just simply leaving us with x minus 4. So this equals the natural log of 4 to the 2x over 3. Now the other thing that we have here is we have a power right here. So this is also a power, which says it needs to come down in front. So this becomes x minus 4 equals 2x over 3 natural log of 4. Now I have this 3 in the bottom. So in order to get rid of it, because it's a fraction, I am going to multiply my entire equation by 3. So this means I'm going to do 3 times the x, 3 times the 4. I'm also going to do 3 times my fraction, and that's it. Okay. So here, I was getting ahead of myself. 3 times x is going to give you a 3x. 3 times negative 4 gives you negative 12. 3 times my big equation here means 3 goes away and leaves me with 2x natural log of 4. So now I need to solve for x. So I need to get all my x's to one side and all my numbers to the other. So I'm going to take this side here and I'm going to move it this direction by subtraction. And I'm going to take the negative 12 here and I'm going to move it in this direction through adding. So I'm going to rewrite my equation, which tells me I have 3x minus 2x natural log of 4 is equal to 12. Now it simply becomes a matter of pull out the x. So I have x times 3 minus 2 natural log of 4 equals 12. And get x by itself. So x is going to be 12 divided by 3 minus 2 natural log of 4. And we have to get an answer here. So in order to do that, it says we got to pull that calculator back out again. And so here, the first thing I would do is start on the bottom. So I'm going to do the natural log. So you see I've got the ln button right here, and you see it types ln, and I'm going to do natural log of 4 and hit enter. Then I have to multiply by 2 and hit enter. Then I have to do 3 minus, and above my negative sign is this answer. So I'm going to hit my blue second. Then I'm going to hit my minus sign. And notice in the calculator you get ANS. Now again, that's for this particular calculator. And this is going to then subtract this last answer that was recorded in there. So when I hit enter, I get this new decimal. Again, I'm going to house this as now the new last answer. And I need to do 12 divided by that number. So I'm going to go 12 divided by. Again, I'm going to hit second answer. And with that, I'm going to hit enter. And you see I get 52.768. And thus that was the result. So again, here again, we have your exact and we have your approximate. Okay. Let's come back up here to the top. Again, I have e to the 3x minus 6 and 10 to the x plus 2. So again, I cannot make e and 10 the same thing, so I have to take the natural log of both sides. So this is the natural log of e to the 3x minus 6 equals the natural log of 10 to the x plus 2. Again, here I have this, which is a power, and I have this side, which is a power. And on both of these, they need to come down in front. So these need to come down in front. And then in this part, this right here, natural log of e, again is going to undo each other. Undoing each other says that it's going to go away. Therefore, this leaves me with 3x minus 6 is equal to, I've got my x plus 2 down in front, natural log of 10. So now I have to work to solve for x. So the first thing I need to do is I need to take this natural log of 10 and I need to distribute it in through my parentheses here. So this becomes 3x minus 6 equals x natural log of 10 plus 2 natural log of 10. I need to move my x, so this right here, I need to move this direction through subtraction. And then I'm going to take this negative 6 piece and I'm going to move it this direction, and I'm going to move it through addition. And so here I rewrite my equation, so I have 3x minus x natural log of 10 is equal to 6 plus 2 natural log of 10. I need to pull that x out, so the x comes out, leaves me with 3 minus the natural log of 10 is equal to 6 plus 2 natural log of 10. Divide everything to get x by itself, so I have x is equal to 6 plus 2 natural log of 10 divided by 3 minus the natural log of 10. And then we again would use our calculator to find that answer. So here, one way that you could do it, which I find or see a lot of students doing, is we like to enter everything in at once. So to do that, I'll show you how. First, you got to open with a parenthesis, and we got to work with what's just on top. So this becomes 6 plus 2 times my natural log of 10, and close it. So essentially what you want to do is you want to make your calculator look like your numerator. You need to input your division, open a new parentheses, and now we're going to do the bottom. 3 minus my natural log of 10, close the parentheses, and hit enter. And here we get an answer of 15.206. So this also equals 15.206. So again, you can see that we have our exact and you have your approximate. Okay. Alright, now we have this one here. So we have 2 to the x plus 1 equals 5 to the 2x. So again, we cannot take 2 and 5 and turn them into each other. So we need to take the log of both sides. So here we're going to take the log of 2 to the x plus 1 equals the log of 5 to the 2x. Now the reason we're taking log is because we don't have e's here. Since we have actual digits or actual numbers, we can take the log. Again, with our log, right here I have a power, and right here I have a power. Power rule says the power has to move down out in front, so I need to do that on both sides, which means this becomes x plus 1 log of 2 equals my 2x log of 5. Now just like before, I need to take this log of 2 here and I need to distribute it into my parentheses so that I can actually solve for x. So here I'm going to end up with x log of 2 plus the log of 2 equals 2x log of 5. I need to take my 2x log of 5 and I'm going to move it that direction through subtraction. And I have to take this log of 2 and I have to move it this way again through subtraction. So we're going to subtract on both sides. So in this case, we end up with x log of 2 minus 2x log of 5 is equal to negative log of 2. I need to pull my x out, so this becomes x times the log of 2 minus 2 log of 5 equals negative log of 2. And then I have that x is equal to negative log of 2 over the log of 2 minus 2 log of 5. And again, when you input that into your calculator, you will come out with 0.274 as your answer. Now, another thing that I see that happens all the time is if we look at this right here, we don't generally like to have the negative out in front. So the one thing that we can do is we could rewrite this using positive, which means we have to flip or switch our negative signs around. So we could have written this as being the log of 2 divided by 2 log of 5 minus the log of 2. And you should get the same result. Okay? So whichever way you choose to do it, however, do keep in mind this negative out in front can tend to throw a lot of people off. Okay? So just be careful with your negatives.